Hello friends, today's question. A bob of mass m is suspended by a massless string of length L. The horizontal velocity v at point A is just sufficient to make it reach at point B. The angle theta at which the speed of the bob is half that of A satisfies. So these are the four options and we are going to find out which of the relation holds true for the value of the theta. So this is a basic figure. Point A is the lowest position where v velocity is given and B is the highest position, and it says that the velocity that is being given at A is sufficient for the bob to reach at point B. And we have to find out a point where the velocity becomes half that of bob A. Okay. Let us suppose this is point C. Here the velocity becomes half. Let us so here v velocity is given and we can solve this question using two different approaches. First, we can use basic formula for the kinematics, and in the second approach we can use the law of conservation of energy. So we are going to solve it both ways. Suppose C is the point where the velocity is half that of point A, and in this case let us say the velocity of C is given as v2 and here the velocity at A is given as v1. Later on we can replace the relationship. Therefore, and we assume that the height of this point C with respect to A is given as h. Therefore, we can find out the height of this point. This is our L. So we can say this will be coming as L cos of theta. L cos of theta. So we can say that it is given that the velocity that is being applied at A is sufficient for it to reach at point B. You can say for the bob to reach point B or make a circular loop. Make a circular loop. The velocity at A should be equal to square root of 5gl. This is the standard formula, and let us call that velocity at this point is given as v1. And we say suppose at point C, which is at a height h above point A, suppose at point C, which is the velocity is v2. So let us first of all find out what will be the height h. So we can say h will be equal to total height L minus L cos theta. So we can say h will be equal to L minus L cos of theta, or we can say L 1 minus cos of theta. So we can use the basic formula for kinematics. Okay. From kinematics equation, you know v square is equal to u square minus 2gs. V is the final velocity, which is nothing but our v2. So from here we can substitute it is v2 square is equal to u is our v1 square minus 2g, distance vertical travel is given as h. So we can put now the values. v2 is velocity at c, which is given as v by 2. v1 is the velocity at a, which is given as v, and s is equal to h. So v2 is equal to, will be coming as v by 2 whole square, and this will be v square minus 2gh. If we solve it, we are going to get this as 3v square divided by 4 is equal to, this will be 2gh, and h is our L1 minus cos of theta, and we already know v square, that is our velocity at point A, is 5gl square root. We substitute value, we get this as 3, this will be 5gl divided by 4 is equal to 2gl 1 minus cos of theta. gl and gl cancels out. We can write this will be coming as 15 by 8 is equal to 1 minus cos of theta. Or from here we can say that cos of theta is equal to minus 7 by 8, which will be equal to approximately minus 0.875. From here we can say that our cos of theta is of negative and approximately equal to 1, and approximately equal to 1. Therefore it will be, we can say, somewhere between 180 as well as pi. So based on this we can say that theta will satisfy the equation as 3 pi by 4 is less than theta less than pi. So here we can say that option number D is the correct option. You can say option D is correct. This was using the equation for kinematics. We can also use law of conservation. Okay. So using law of conservation of energy, which states that energy at point A will be equal to energy at point C. Energy at A will equal to energy at C. So energy at A we can write will be equal to half m v1 square. Energy at C will be equal to half m v2 square plus mgh, because at C it is having both energy, velocity as well as, kinetic as well as potential, whereas at A it is having only potential energy. So our m cancels out throughout, and we know that V1 is equal to V and V2 is equal to V by 2. And H also we know, H is equal to L1 minus cos of theta. We substitute the value, we get half V square is equal to 1 by 2 V square by 4 plus GL 1 minus cos of theta. So we can solve this. We get this as half, and V square we can take it common, so this will be 1 minus 1 by 4 is equal to GL 1 minus cos of theta. Value of V also we know that our V is equal to square root of 5GL. So we can write this as half 5GL. This will be coming as 3 by 4 is equal to GL 1 minus cos of theta. GL cancel out. Once again this comes as 15 by 8 is equal to 1 minus cos of theta. This is same as this part. Therefore, from here we can say that cos of theta is equal to minus 7 by 8. And once again, we can say that our theta will be less than pi but greater than 3 pi by 4. So this question can be solved using both ways, conservation of energy as well as basic kinematic equation. In both the cases, we arrive that the option D is correct. This completes the question. Let me write it here using this is second method. So this completes the question. Thank you.